Okay, so you've done the questions from the worksheet that are from previous year's state exams. I have 4 other examples to work out with you. Each time I'll read the question, I'll pause to allow you to try the question. I would encourage you to do so. There are some sneaky ways that proportional reasoning shows up, and I want to show them all to you. So here's question 7. At a party, the ratio of boys to girls is 2 to 3. If there are 30 people at the party, how many are girls? Pause. Do the question. Do the question. Okay. Some of us are going to say, wait a second, boys to girls is right because this is boys and this is girls and that's neither boys nor girls. So we don't know where to put that. So we're in a little bit of trouble and we just get rid of the whole thing and we start from scratch. We know that the ratio of boys to girls is 2 to 3. So for every 2 clusters of boys, there are 3 clusters of girls. That's what the ratio implies. For every 2 clusters of boys, there are 3 clusters of girls. And altogether, there are 30 people at the party. Well, if there are 30 people at the party and 5 little clusters, I don't have to tell you each of those clusters is 6 people. So where are the girls? Here are the girls. How many girls? 6, 12, 18 girls. This is a very common way to display proportional reasoning for small children. Small children understand this. When we say the ratio of boys to girls is 2 to 3, we mean exactly this. And so each little cluster has to be 6, and so there are 18 girls. Other people work this out by saying, if the ratio of boys to girls is 2 to 3, then the ratio of girls to people is 3 to 5. And if the ratio of girls to people is 3 to 5, then we can figure out how many girls there are among 30 people. And this would have been something you would have worked out when you were young. And sure enough, you get 18 girls. That's the other way to think about this proportionally. So this piggybacks directly off of that. Anna, Beth, and Kathy have stickers in the ratio 3 to 5 to 7 respectively. If Kathy has 48 more stickers than Anna, how many stickers does each girl have? Pause, do the question. Pause, do the question. I'm going to work it out 2 ways for you. I'm going to work it out in a picture form, which seems to be intuitive. Going to work it out with algebra, which is probably the way some of you tried it. When we say that they have stickers in the ratio 3 to 5 to 7, we mean that if Anna and Beth and Kathy were to lay out their stickers in little clusters, Anna's got 3 little clusters, and Beth has 5 little clusters, and Kathy has 7 little clusters of stickers. That's what we mean, 3 to 5 to 7. Now, Kathy has 48 more stickers than Anna does. Here's Kathy's extra. Anna stops here. Here's Kathy's extra. This is 48 stickers. Well, if this is 48 stickers, then I don't have to tell you that each of those clusters is 12. And if each of these clusters is 12, you be darn sure that each cluster is 12. So how many stickers does each girl have? Well, Anna's got 36 stickers, and Beth has 60 stickers, and Kathy has 84 stickers, and you can confirm that those differ by 48. You may have learned how to do this with algebra. You may have learned to say that Anna has 3x stickers and Beth has 5x stickers and Kathy has 7x stickers. And so when we say Kathy has 48 more stickers than Anna, we mean that the number of stickers Kathy has is 48 more than the number of stickers that Anna has, and so x is 12, and it follows the same way. So all the picture does is it says the x's that you're used to using from your high school experience, those are just squares. And kids can understand squares. It's a very algebraic way of thinking for a 9 or 10-year-old to get a hold of. And I would encourage you to do that. Question 9. A Boeing 747 jet is 230 feet long with a wingspan of 195 feet. Scale model of the plane is 40 centimeters long. How many centimeters is the wingspan? Pause. Do the question. Pause. Do the question. Pause. Do the question. So you have this jet, and the jet is 230 feet long, 195 feet in wingspan. And then over here, you have a scale drawing of the jet, and the scale drawing is 40 centimeters long, and we want to know about its wingspan. If we're thinking proportionally, we're going to compare like things with like things. The wingspan is to the length. The wingspan is to the length. And we can cross multiply like we did when we were young and get that the wingspan is about 34 centimeters. And that makes sense. The wingspan is almost as big as the length. The wingspan is almost as big as the length. The wingspan is almost as big as the length. This is a standard proportions question, so I would hope that you would know how to do that. This is not a standard proportions question, but it is pretty much Algebra 1. So let's see about it. 2 hoses are used to fill a pool. One hose would fill the pool in 3 hours. The other hose would fill the pool in 5 hours. Both hoses are turned on at the same time. How long would it take them to fill the pool? Pause, try the question. Pause, try the question. So one hose is able to fill the pool in 3 hours, all by itself. One hose is able to fill the pool in 5 hours, all by itself. We want to know how fast the pool fills if they work together. So there's lots of things that people try to do with these numbers, the 3 and the 5. Most notably, folks try to take the average, and that's just weird because the red hose working by itself can do the job in 3 hours. So if the blue hose helps, then the answer is less than 3 hours. So no sort of averaging gets us what we want here. What I'd like to do is I'd like to consider what happens in 1 hour. Because I don't know about the hoses just generally, but I know about what the hoses will do in 1 hour. In 1 hour, the red hose fills 1/3 of the pool. And the blue hose fills 1/5 of the pool. Oh, wow. Together, you add those fractions. In 1 hour, they fill 8/15 of the pool, working together. So now you can think proportionally. In 1 hour, they fill 8/15 of the pool. I want to know how many hours it takes to fill one pool. And so we cross multiply and we do what we do, and sure enough, almost 2 hours to fill the pool. Almost. almost 2 hours to fill the pool, which makes sense. The answer should be less than 3. It's probably about 2. This makes sense. These are proportional reasoning questions that you should know how to do. The next time we meet, it's exam 2. I have nothing but well wishes. Good luck. Hope our paths cross soon.